Hey, thank you for stopping by. This is A1 Math, and today we're talking about similar polygons and also working them out with word problems, showing them in a context setting. So let's start off by going over a few similar polygons and using the fact that they're similar in order to solve missing sides to that polygon. If you take a look at number one, you have a quadrilateral, two quadrilaterals that are both similar. The trick here to solve for the missing value, which is x here, is to match it up with its equivalent or corresponding piece on the other quadrilateral. Okay. Once you do that, you're halfway there. The next thing you want to do is find another ratio that's equal, but in order for it to be equal, it has to first come from your first polygon to your second, and second, make sure you match it with corresponding pieces. And you could pick any corresponding piece. The 26 would go with the 13, 24 would go with the 12, and the 22 would go with the 11. But I just decided to go with the 24 over 12. Okay. Now, once that's done, all you got to do is go ahead and cross multiply and find your value. We'll have 6 times 24. And that's equal to 12x. Six times 24 would be 144, equal to 12x. And then you go ahead and divide by 12. And that'll get us x is equal to 12. Okay, and we can compare the 12 over here and see how it's smaller than the other pieces here. So that seems to make sense. X is equal to 12. Let's take a look at another example. Again, we want to match the corresponding piece from the first polygon to the second. This was a little bit trickier. You could tell that if you look at the x and the 13, it's on these two longer pieces. But the 13 most likely is longer than the unknown x here. So since 169 is longer than 130, the 130 would correspond with the x. So I'll put 130 over x. And I'm going to set it equal to a smaller number here, 52 over 4. And like I said, you could pick any ratio. So again, we cross multiply. We get 130 times 4 is equal to 52x. 130 times 4 is going to be 520, equal to 52x. Then divide by 52. And x is equal to 10. All right, so that's similar polygons when you have a missing side and using the fact that they have the same scale factor in order to find the missing pieces. Okay, now that is used in the real world. I'm going to show you some examples. Here's a model airplane. The model plane is 10 inches long. If it was built with a scale of 1.5 inches to 6.2 feet, then how long is an actual real plane? So what they're saying here with this scale factor, 1.5 inches to 6.2 feet, is that for every 1.5 inches is 6.2 feet in a real plane. So you need to figure out, well, if the model was 10 inches long, how much would the actual airplane be? Well, you'll take the scale factor and set it up just as it is. You'll put your 1.5 inches divided by 6.2 feet. And then we'll go ahead and take the 10 inches. So since we have 10 inches, we will make sure we put that in the numerator to match up with inches here. So we've got 10 inches. And we're going to divide it by our unknown feet. And the same thing we've been doing, we're going to cross multiply here. We have 10 times 6.2 equal to 1.5 feet, or 1.5x. Now, 6.2 times 10 would be 62 equal to 1.5x. Go ahead and divide. And that's going to get us 41.333. And since we rounded to the nearest tenth, it'll be 41.3. Okay, let's take a look at our next example. Okay. If a 7.6 foot tall cardboard box casts a 10.6 foot long shadow, then how long is the shadow that a 1.9 foot tall globe casts? Let's take a look. Well, they're giving you two items and they both cast a shadow. And that shadow is going to have the same similarity. So what we're going to do is take the height, the actual height, and the shadow height for the cardboard box and set that up as our ratio. So we're going to do 7.6 feet and place it over 10.6 feet. Draw a line, separate these. All right, that'll be equal to 1.9 feet over x and then we cross multiply. Now when we cross multiply, we'll get 1.9 9 That's 1.9 times 10.6 is equal to 7.6 times x. Okay, when we multiply the 1.9 times the 10.6, that's going to get us 20.14 equal to 7.6x. Okay, and when we divide by 7.6, that's going to leave us with x is equal to 2.65, but round to the nearest tenth, it's 2.7. Okay. So those are a couple of examples of what to do when you're given a scale or you're dealing with a shadow as far as a real world context, as far as figuring out the length. So again, this has been Similar Polygons. I hope you enjoyed this lesson, and thank you for stopping by A1 Math.